So the background of our work here is in practice, we have logic programs and we have argumentation framework currently. So the two very well known formalism for in knowledge representation reasoning, and here you can see that logic programming represents the knowledge in the form of facts and rules, and support is very well known for like a good mechanism, formalism for dealing with common sense reasoning. And argumentation framework represents the knowledge in the form of arguments and attacks, and supports the kind of like it best suits in our view as an argumentative reasoning. So basically, the two formalisms specify different types of knowledge and realize different types of reasoning. Even though one can view, one can implement the other, but usually, let's say that the transformation from an argumentation to logic programming, it doesn't look very like natural in our view. So, and in our daily life, we observe that we often use the two modes of reasoning, the two framework very interchangeably. And let us see the example here. So in the context of the COVID, and so like it is, we can have this kind of rule, like you should get the vaccine if it is safe and it is effective, but you shouldn't get it if it is not safe. But as an user or consumer of the information, like most of us are not expert and do not know whether the vaccine is safe or not safe. So now, when we need to decide whether the vaccine is safe and effective, we ask the expert, right? We ask our doctors, our family doctor, should I get the vaccine because it's safe, or is the vaccine safe or not safe? So, and then the problem for us is that it is often the case that multiple experts have different opinions, and this, for example, you can see very easily right now. The problem with the COVID vaccine is really this is what happened, right? Now here in this simple example, we observe argumentation among the experts and then take it into account to make the decision. So here we make the decision using a logic program, but the decision the result it depends on the argumentation, right? So on the others, so conversely, this is the same thing also happened. Now look at if we look at the problem, like people are debating whether the global warming is occurring or not. And scientists and politicians make different claims about that based on the evidence and the scientific knowledge. So argumentation framework is great for you to use for represent the debate, to why arguments appearing in the argumentation framework are generated as a result of reasoning from background knowledge of participants. So here we have two people, like one say it is real because the scientific knowledge that she has, and this man have like it is a hoax because of this. So in here in this example, the arguments in the argumentation framework are supported by the background knowledge of each of the person participating in the debate. So what that motivate our work. So like so basically in this example, the reason of private knowledge, it encoded a logic program by argumentation in the it basically a public space that it encoded the argumentation framework. And it is very natural to distinguish the two different types of knowledge and interlink them with each other. So our goal in this paper was to introduce a new framework that we call LPAF and AFLP that to interlink logic programming and argumentation framework. So LPAF is the result of argumentation in the argumentation framework for reasoning in the logic program and vice versa. AFLP is a result of reasoning in the logic programming for arguing in the argumentation framework. And then we extended the framework to bidirectional framework in which AF and LP, so argumentation, and can exchange information with each other. So let me have one slide background on logic programming and argumentation framework. We view the logic programming as a finite set of rules of the form disjunction P1 to PL if Q1 to QM are true and not QM plus 1 to QN are false. So this is so where PI and QJ are proposition variables. And we know that there are different semantics for a logic program. We would denote that a logic program LP under the semantic mu, like grounded, like well-founded semantic, or preferred semantic, or stable model semantic with this LP mu. So whenever we say LP mu, we mean that the logic programming is considered under that the semantics mu, and then we apply the argumentation framework like the abstract argumentation framework from Dong, where it is a pair of arguments. It's a set of and then the attack relation. Similar to logic programming, argumentation framework have many semantics. For example, the grounded semantic, the stable semantic, the preferred semantic, and that we would denote it with omega. And whenever we say AF omega, then we say that we meant to mean that the argumentation framework AF under the semantic omega semantic. Right? So how do we link the two of them together? So so now let me introduce the LPAF. So this is to use the result from argumentation to reason in logic program. So assuming that we have argumentation framework AF, so the program LP is partitioned into two parts. One is a set of rules that have that basically the rule is here it's free. It refers to some argument in the argumentation framework, and the other set of rules that is free from arguments. So basically, the body of the rule does not. So the body of the rule is intersection with the argumentation. Arguments is empty, it's non-empty and empty, right? And then we say that an argument A is referred by a logic. The argument it appears in the logic program. We define LP. LP restrict to A, where it's a set of arguments in A that is referred by LP. Given an argumentation framework AF and a set of arguments, so the calligraphic A here is a subset of the set of all possible set of arguments. We say that a mu model of the LP is extended by A is a mu model of the program LP together with the set of argument that its intersection, so that appear in the program restricted to this argument set of argument for some years. So that basically, if I have a collection of set of arguments, I take one out of that and then added them to the facts of the fact of the program LP. Then a mu model of that program is a mu model we call that a MIM model of LP extended by this collection of arguments, set of arguments. And then when A is empty, then we say that a MIM model of, so we take that as just simply the set of rules that does not depend. So this not refer to it, that the set of free rules that free from arguments. Okay. So then we define the simple LPAF framework. Here is a pair of LP mi and AF omega. And when the AF has a set of omega extension, E omega here, E1 to EK, and then we say that an LPAF model of phi of this framework is defined as a MIM model of LP mu extended by this set of extension, right? So this is basically the formula. When the AF is inconsistent, it doesn't have any extension here, and then we say that the LPAF model is basically the set of rules, the MIM model that consists of rules that are free from the arguments in AF. So well, here it's a few examples for that. Like if we have this, we consider this program under stable model semantic. So we can have like, if there is nothing, then we will be able to, we say that we conclude that Q is true, right? Because A is not there. But if we consider that, interlink that with an argumentation framework in which we have like two stable extension A and B, that's obviously here, and then the framework, the LPAF framework has two models. Like when we add A to that, then we have A and B, like with A and B, and then we add B, then we have just Q. Noted that when here we don't have B is not in the it refers to the in the logic program. Therefore, we do not add the fact B into the program, and therefore it's just only Q. If we take omega as grounded here, and then the argumentation framework has only a single extension, empty set. Then in that case, this LPAF have only one model, Q, right? So that, and then now, like in the case of like another example where we have P. So in this case, we have P is not A and Q is not P. So then we have, say, if we have, because node A is not appear, so basically we have just only P. But if we use a stable model, it interlink with this condition. This one doesn't have any stable model because of the conflict between A and A here. Then in this case, because of the inconsistency of the answer of the AF, we have only one single LPAF model Q here, right? Now that is, so we can prove a number of properties for the LPAF model. So for example, we can say we have that the inclusion relation between the AF, within the same AF under the different semantic, because of we know that grounded extension are subset of complete extension or stable subset of peaceful extension, and so on and so forth. We have this basically this relationship between of LPAF model for a framework, right? With the same logic programming, but different argumentation framework under different semantics. Now, secondly, we can also have that whenever if we have two programs that are uniformly equivalent, then basically we also, so if the logic programming part are equivalent, then the interlink with a argumentation framework in the same semantic will give us the same set of LPAF models. So now we can generalize this notion of LPAF to define. It's like a tuple. A framework is a tuple, a collection of logic programs, and then a collection of argumentation framework under the different semantics here, right? So in general, basically we have multiple agents that are reasoning using different logic program under different semantics. But this part here, the part of argumentation framework are basically open to them, and they will make use of that to make it. So we will define so the LPAF state of this framework as a tuple sigma 1 to sigma m, and each of that is a sequence of the simple LPAF. So this is a combination, a cross product of each logic programming with different argumentation here. I think that I will just skip this slide for the interest of the time. I think that it basically defines the general LPAF, what is the general models of a general AF program. So what I wanted to emphasize is that the general LPAF has a modularity property where it can be partitioned into smaller framework, and then the introduction of the new logic program to this can be done incrementally. Now, I wanted to spend the time on presenting the other way around. So how do agents use the logic programming result to in the argumentative reasoning? Now, assuming that we have a logic program and a argumentation framework, we assume that no rule in the logic programming has an argument in its body. So we use a BLP here to denote the Herbrand base of the logic program. Given a AF argumentation framework and a model of the model or a subset of the Herbrand base of the logic program, we say that the AF with support from M is defined as a new argumentation framework with the same set of arguments, with a different set of attacks as follows. So R prime is obtained from R by removing all of the attack against argument that appear in the set M here, right? So A belongs to the intersection of A, M, and X belongs to A. So anything that is attacking any elements in M removed. So basically, we have a new argumentation framework in which every tuple attacking the element in M is removed, and as a result, every argument included in M will be accepted in the argumentation framework, in the new argumentation framework. And then with that notion, we can define the omega extension of the argumentation framework, supported by a collection of models in the Herbrand models of the logic program in a similar fashion as we have done before. We take a model in this collection and then revise the argumentation framework accordingly, and then we have a new argumentation framework that then that and the new and use an omega extension of that new argumentation framework as omega extension of that of the original one and supported by M. And with that, we can define the notion simple. We can define the semantic of a simple AFLP framework that is defined as a pair of. So here the argumentation framework comes first, and then the logic program come next. In a very familiar fashion. So when the logic program has some new model, then the AFLP extension of phi is basically defined as using the notion of AF omega supported by this collection of mu model of the logic program. In the case of the logic inconsistency of the logic, we do the same thing. We do the same thing. We say that then the omega extension of the new of the AF would be like the one that is to remove everything that is related to the logic program, right? So that as an example we have here. Consider this case where we have two arguments, and then the like mutual exclusion of between the two arguments, and then we have a stable a logic programming. We have like A if P and P if not Q and Q if not P. So in this case, the logic programming has two stable models. One is AP and the other is Q. And then when we when we have updated that with the AF, so we have this, and then we have the original one as a result. So we have this AFLP have two extensions. One is A and B here. So as you can see, that doesn't change anything. But if we use the grounded extension for the argumentation framework, then we have two of them, like one is A and the other is empty set. And here again, like this similar example where we have like three arguments, A, B, and C, A attack B and B attack C. And we have the program where the program doesn't have any the stable model, so the set. So therefore, the AFLP extension of this case, we have just B as a say, for example, grounded extension of this one, right? And
it's more or less time to conclude pretty soon.
Yeah. So we can prove a number of property of the similar property that we have before. Like I will just skip this section and now skip also the description of the general AFLP. And then so we can show in the paper the framework can be extended to like bidirectional LPAF, and then this for example. I think that I will probably conclude from here with different. So we quickly mention the different properties that we can prove for bidirectional LPAF and bidirectional AFLP. But finally, I wanted to just quickly remark that this new framework enables to combine the different reasoning tasks while keeping independence of each knowledge representation. We in the paper we show that it could be used for several KR frameworks, and wanted to quickly mention just in case that like many of you probably familiar with the multi-context system, and our framework share a view similar to the multi-context system, but the semantic defined in this by our it different from the equilibrium semantics. And quickly, like the complexity of the problem, when we combine them, the complexity doesn't reduce, and we could also investigate the labeling semantic of argumentation framework, and three-value semantic of LP could be done in a similar fashion. So I will conclude here and wait for question.